All right, we are in the office today doing some quotes, performing some layouts, and cold calling some customers. We got a lot going on today. But I wanted to jump on here and do a video for a ICF potential home. The individual got a hold of me and said, hey, what do you think about an ICF house in this location? I said ICF houses typically work in any/all locations, but he doesn't have a print. That doesn't really matter to me. That's not something I'm concerned about. So let's jump into this video and get this customer what they need. So we have our blank sheet of scratch paper here. This is going to be called Mike's house. He wants ICF and his goal is to get to 1,500 square feet. Now, be mindful, as stated mere seconds ago, there is no print for this. However, this customer is familiar with an ICF home that we have done, and they really like the design of that house. Not necessarily just the ICF portion of it, but the overall layout of that home. So what we've got to do, I've ran some calculations to determine what square footage the previous house was. Now I've got to figure out how to shrink that down a little bit and get it to 1,500 square feet. So let's jump into that and see if we can figure this out. Well, all right, so here's what we do know. We do know the shape of the previous home that was built out of ICF. So we're going to create a print for this potential customer going off of the home that we built previously. So let's get this overall shape drawn out here, and then we can start doing some dimensionals to determine what the actual size of the house needs to be to go from a home that is roughly 2,400 square feet down to a home that is as close to 1,500 square feet as we can get. Now, with all that being said, their wants is 1,500 square feet. With this shape of a house, I'm not 100% confident that we can hit that exactly. However, I do believe that we can hit that really close. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm counting the squares because this house, I wouldn't call these bump outs, even though they simulate a bump out. And the reason I wouldn't call these a bump out is because it's a porch on the back side of the home. And I'd almost call this an indention in the home instead of two bump outs. If there was multiple features, I would probably call it a bump out, but in this case, we're not going to call it a bump out. We're just going to call it an area for a porch. So this is the back porch. And with the back porch being there, what we have to keep in mind is this is not square footage for the home. So we can take 1,500 square feet and we can divide it by an even number. Let's just go with, when I say let's just go with, the current house's layout is wide and not quite as deep. So I don't want to call it a 50-50 split, but it's pretty close. So this current existing home has this U shape or horseshoe shape, and I'm not concerned about what they're going to put on the inside. All I'm really concerned about is the total square footage. However, if I was to make this dimension 10 feet and this dimension 10 feet, what we have to keep in mind is we're going to lose 2 feet of that, 2 foot, 1 foot on each side for a total of 2 feet. And if this was to be a bedroom, I wouldn't want the bedroom to end up being, because you got ICF here, ICF here, ICF here. So you take 2 feet off of that, 2 feet off of that. I don't want the bedroom to be 8 feet. So we have to have a dimension large enough. And if we were to just go off of a good sized bedroom, you're kind of going to want something in that 13, 14, 15 feet range. So I believe these back here need to be somewhere around 17 feet outside to outside to ensure that the inside is 15 or 14. 17 is going to get you down to 15. 16 is going to get you down to 14. You guys can see where this is going. But if we were to factor the overall dimension, and let's just start with a 1,500 square feet. You can see that I have that here on the calculator. And then we're going to divide that by the length of the house, which with the way you enter this house, it's the width of the house. But regardless of that, let's say it's 60 feet. That's going to give us 25 feet going this way. And I'm not 100% positive with the square footage of the porch that's going to be taken out of that where we're going to go. But let's bump that out just a little bit, and let's call this width of the home. We can change these dimensions. Let's all keep that in mind. This is not something that is dead set. This is a starting point. And I'm not doing this on time lapse because there may be some of you that view my channel that ultimately one of these days will want to build a home or have a home built or be involved in building your home. So this is kind of a down and dirty, here's how you can get started, and a contractor can give you some estimates, some rough numbers as to what something like this is going to cost. And I state that because that's exactly what I am doing for this customer here. Am I charging them for creating their print? No. But we're 5 minutes into this video and we're well on our way. We're going to bump that out to 61 feet. Now, I know for a porch, you don't want something so small that you can't utilize it. You can't put a table and at least a couple of chairs on it or do an outdoor kitchen or something like that. So let's kind of get a guesstimate here on our porch so that we can figure out what it is going to consume square footage wise. If these were 17 feet, let's just use that as a rough guess. So we're going to have two widths at 17 feet because that gets us down to a 15-foot wide bedroom here and here. Again, I'm not really worried about the inside. However, got to make sure that we lay this out to where it can at least be usable space in these two bump outs, even though they're not really bump outs. So we'd have 17 times 2 because you'd want these to be equal, I would think, symmetrical, so that you can lay out same bedroom sizes, same bathroom sizes, or break it up evenly, and you still have the same outside dimension. So that's going to be 34 feet. Then we've got to subtract that from our 61 feet. That leaves us with 27. I don't really like that number. But if we add 6 inches to each of those, so then we have a 15.5 foot bedroom, and just take that down to 26 feet, that would be an even number for the porch. That's going to be a 26 foot wide porch. And then if we go this way, 10 feet gets kind of tight. So why don't we make that 12 feet? Again, everybody, please keep in mind, this is guesswork here, and it might end up pretty close, but we shall find out. So we're going to make 26 wide by 12 foot deep, and that's going to be times 2 because this wall is 12 feet as well, making those bump outs the same dimension, either out or the same dimension in, so that you don't have your foundation stepping back a little further and or your ICF walls. So if we make that 12 by 26, that's going to be a total of 312 square feet. Now, with that being said, the current design is basically half. So 61 feet divided by 2 is going to be 30.5 feet. That doesn't really work out that well, so we need to go something like 32 or 33 feet. Well, let's see. 61 times 30. We're going to bump that down 6 inches. Minus 312. Whoops, that's 321. 312. That gets us to 1,518 square feet, so we're really close. But now I got to think about if that's a 15 by 15 bedroom. Let's go ahead and put this dimension over here. This is going to be our depth dimension. I know a lot of you guys might be like, dang, it takes you a long time to draw this out. Yeah, I don't have AutoCAD, so I have to create a print with my hands. That's going to be potentially 30 feet. Well, that leaves me with 15 feet up here. And that if they make this an open area, so that the current home has a open feel to it, you've got a bedroom, an office, another bedroom, a bathroom, and then all this is open in here. But if that bedroom comes out 15 by 15, that's going to be 3 feet past this wall. So a short wall can be framed up here. That only leaves us with 15. Well, actually, it's 28 feet, right? Because we've got ICF and this is outside dimensions. So 28 minus 15, that only leaves you 13 feet for a bedroom in the front or an office. That didn't work out very well. Personally, I don't think that works out very well. If we were to increase that by a foot, so we need to increase that by 3 feet. So if we go 33 minus 2, which is the ICF, that leaves us with 31, divided by 2, that's 15.5 feet for each room. You take your 2x4 wall out of that times 2, that leaves you 2 15-foot rooms. So that actually what we need to do is 33 feet here. That's going to increase the square footage a little bit, but I don't think that's going to be a big deal, and that ensures if they want all the bedrooms on the left side of the home, they can build one dividing wall and finish the 2 outside walls, and they still end up basically at a 15 by 15 foot bedroom. If they put a bathroom there, they can have a large, like a master bedroom and a master bath. The bedroom can be a little bit larger and the bathroom can be a little bit smaller, and then you could put kids' bedrooms on this side of the house and leave the entire center section open, basically. Because that's a 26-foot opening here. Be mindful. I know I didn't draw this symmetrically. The bump outs look like they are wider than the porch, but they're actually not going to end up wider than the porch. We did that math earlier, but let's do that again. 61 feet minus 26 feet, that's 35 feet divided by 2, 17.5 feet, right? Yeah. So these bump outs, get our dimensional lines here that tells us where the dimensions go to and from. We know that we're making these the same size. I don't know if I'm going to title this video ICF house or drafting an ICF house, but ultimately what we're doing here is we're giving them a rough sketch to get them an idea as to what kind of sizes you can get out of a 1,500 square foot home. And again, now 17.5 feet, so that's 17 feet 6 inches. So if I were to draw this symmetrically, the porch would actually be bigger than the bump outs, but I'm not really worried about the details of the porch because it's just a rectangle. It's going to be poured concrete porch, and they can do with it what they want. When it comes to the actual house, that's where things get a little bit more interesting. So that gets us broken down to the overall outer dimensions. Obviously the 61 feet is going to be the same back here, and the 33 feet is going to be the same over here. They're going to have a main entrance somewhere in this area here. We can kind of draw that out. I'm assuming they're going to want to go with some type of a double door or a large entrance door. We'll just kind of rough that in just as a potential. So with all that being said, we know we have 312 square feet of porch. Now we have 61 feet in width, 33 feet in depth. That gets us to 2,013 square feet. Now we have to subtract the porch because that's not living space. That ends up getting us down to 1,700 square feet and very usable space. The only other option we would have if we wanted to shrink the overall dimensions would be to shrink the porch. We do have 200 extra square feet in here. That's above and beyond what they wanted. But I do have a concern that if we go any smaller with the porch, it might not be a good usable space. So I think we're going to stick with this. I know it's a couple hundred square feet more than they want, but it allows you to have multiple. You could get 4 15 by 15 squares in here, and if you wanted to cut those down to 13 by 13, you could have a 4-foot closet for both rooms and put a door in each room, and they could access 2 separate sides of the closet there. So I think we're going to stick with that. That's going to get us, like stated earlier, 1,701 square feet usable. Now what we have to do is figure out all of our dimensions and how many blocks it's going to take. And this customer wants this performed 2 different ways. They want this performed with a basement, and they want it performed without a basement. Even though you go without a basement, we have a frost line in our area at 18 inches. So we still have to, at minimum, get that foundation 18 inches in the ground, and then put 1 course, if you will, of ICF on top of that foundation to bring us back up to grade. I've been told that this site is relatively flat. I have not gotten boots on the ground. That'll be a separate video. But with being told it's relatively flat, we're going to assume that we don't need multiple blocks high to get the stem walls up in a crawl space scenario. Whereas a basement scenario is going to take us all the way beyond the frost line. I don't recommend a basement any shorter than 9 feet of ceiling height. Well, 9 feet definitely gets us past the frost line. So I'm going to start doing some math, put you guys on time lapse, start doing some math and figuring out how many blocks it's going to take. And we'll get to, I'll describe to you guys how the blocks end up, the quantity of blocks, quantity of corners, why it's that way after the time lapse. All right, so this would be the basement and first floor, and to ensure that we have 9-foot ceilings in the basement and 9-foot ceilings on the first floor, because no one builds with 8-foot ceilings anymore, right? We got to go 10-foot 6 in the basement, assuming they're going to be using LVLs and they're going to be an 18-inch tall. If they end up only using 2x12s, we can shave some of this off, but we still have to calculate the product because we can only cut so much off the product. And then a 9-foot ceiling. So an all-in, on top of footer, 19-foot 6 total height of walls. We have 212 foot of walls. That gives us 7 courses in the basement, 6 courses on the primary level, or 186 blocks on the basement, 56 corners. 159 blocks on the first floor and 48 corners. And then what we would do is an 8-inch formadrain. That would be a foundation underneath of all of this with 2-foot spacers. So we're going to need 40 pieces of formadrain, 16 formadrain corners. I forgot the couplers now that I'm explaining this to you guys, which I can figure that out here in just a minute. We need grade stakes to hold the formadrain, 112 of those. 24-inch spacers. Now what does that mean? We're going to utilize the 8-inch formadrain to make the actual foundation, but we need to space that foundation, and what we use is 2-foot wide spacers, which couple, if this was the formadrain here and you had a second line in here, that creates that 2-foot gap and holds it at a 2-foot gap while you pour the concrete within the actual footer. The octagon plates are for the floor joists that'll separate the basement from the primary level. We need 60 of those. 60 J brackets. Whatever quantity you get of octagon plates, you have to get the same quantity of J brackets. And then truss plates. I have calculated this on having truss plates spaced at 2 feet around the entirety of the home. I have no clue what the truss layout's going to be. Obviously, I created this print. I'm not going to create a roof line print. So by calculating these truss plates at 212 plates, that ensures I can put 2 plates every 2 feet around this entire home. So if they've got trusses running all types of different directions, if they end up with a hip back here or something, that allows to ensure a truss plate is spaced 2 foot around this entire house. So that's for the basement. Now we got to go to the crawl space only, which would be 18 inches in the ground, 2 courses of crawl space, and then the rest of the home being the 9-foot wall that we had on the primary level within our first drawing. So let's get to the bill of materials for this one, and then I will explain all of the totals for that one as well. We've got the totals for the crawl space potential, and I know I'm casting a little bit of a shadow here, but to walk you guys through this, the crawl space will be 3 feet tall, which is 2 courses of block. So for the crawl space, we need 36 blocks and 16 corners, because there are 8 corners, and there will be 2 courses. 8 times 2 is 16. For the first floor, 9-foot tall ceilings, that's 6 courses. We have 159 blocks, 48 corners. The total ICF package will be 195 blocks and 64 corners. We've got all of our former drain as mentioned earlier. And the reason I break this out in this scenario is because the crawl space is going to have the exact same foundation as the basement. The only difference in these two is this will have basement ICF walls and this will have stem walls. The other difference you will see is the total of blocks and also the total of backfill, be it for the number 5s. Number 5s is the backfill that goes around the outside that allows the water down to the former drain to then go out and exit. You'll see here on the crawl space, I didn't write it all the way out, but the backfill number 5s is only 20 ton needed, and the backfill for the 11s is 50 ton. The backfill 11s isn't a necessity. However, when you're in this crawl space, you at minimum want to get your rock up to the top of your former drain so that you can put a vapor barrier down and ensure any moisture that does get within the crawl space, because it's inevitable. Just like underneath a basement concrete floor, it's inevitable. You're going to have hydraulics pushing water up in there, which is why the former drain comes into really big play here, because it drains the inside and the outside of the foundation. So we're going to put 50 tons of 11s in here, which will get us up to that 8-inch height of the former drain, and we'll be able to lay that vapor barrier down. But as mentioned a minute ago, the former drain's the same, the couplers are the same, the stakes and the spacers are the same, the octagon plates are the same, and the truss brackets are the same. Biggest difference is quantity of ICF. So if we come down here to this basement, we still have the same 212 foot of wall total, but the basement is 10 foot 6. Again, that allows for a floor system to be placed, and you still have a 9-foot ceiling height in your basement. So that's 7 courses, or 186 blocks, 56 corners. And then the primary first floor is a 9-foot ceiling, 6 courses, 159 blocks, 148 corners, for a total of 345 on the blocks and 104 on the corners. And if you remember up here on the crawl space, that was 95 and 64. So the savings, a lot of people ask, Well, how can I cut some cost? Obviously, taking a basement out of the equation cuts some cost. You still have to have a foundation. You still have to have frost-proof footers. So the crawl space still has to have some ICF to get you below frost line and then slightly above grade. So you've actually got some room to get down in there and do something instead of having your floor joist this high up off the actual ground. Some people we've seen pour concrete floors, true 4-inch concrete floors in their crawl space, so they've got a nice flat surface to work on. Other people let us backfill with rock and throw a vapor barrier over top of it. It all comes down to the customer in that case. So if you are pouring a 4-inch floor in your crawl space, the only savings you have is the actual wall height, ICF cost, and concrete, and rebar, and a little bit of labor cost taken out of the equation. Whereas if you don't pour a concrete floor in your crawl space, you've got the entire basement wall minus the 3 feet for the crawl space. You still have to have the footer, but you mitigate ICF, basically 7.5 feet of ICF, 7.5 feet by 212 feet long of concrete, and the rebar schedule that would go into that wall. So that's where the cost savings comes in, and the basement floor, if you don't pour a floor in your crawl space. So hopefully that gives you guys a good rundown. This was a rough draft of a potential print for this potential customer, ICF-wise. My next steps are to give this customer an estimate. None of this is set in stone. None of this is guaranteed. So this isn't an actual quote where the dollar amount will stick. They may make some changes. They may want me to shrink the house. They may want me to expand the house ultimately once they see the actual size of rooms that they can end up with. So this will be an estimate. My next steps will be to plug all of this information into the spreadsheet from the ICF supplier, come up with an ICF total material cost. That's going to be rebar, bracketry, truss plates, ICF itself, any attachment points for the ICF, the foundation being the forma drain, the spacers, the stakes, the rebar that goes in the foundation, and the drain connection that goes into the foundation. And that doesn't matter if there's a basement wall or a crawl space wall. All of those things can be put into the same Excel spreadsheet to come up with a total BOM, is what I call it, bill of materials. Once I have that material cost, the next step in this work is factoring the concrete. Now, a lot of people try to figure out concrete, and there's a very simple way that I do this. And I basically, excuse me, have an app. Right now I'm going to Google it. It's called Concrete Calculator. It's Concrete Network is where I go. And what pulls up is you can factor this on a slab, or you can factor this on an actual wall. To me, it really makes no difference. It's going to give me the same yardage as long as I put my dimensions in there correctly. So I'm going to switch you guys over to where you can see what I'm doing here and how I get this calculated. Right now you can't see it. Hopefully you guys will be able to see my phone screen. I know sometimes phone screens get a little bit interesting, and it may actually be better to shut this light off. So we know our wall thickness is a 6-inch cavity. And this might not be clear for you guys, but I'm going to tell you what the dimensions are. We know our width from our original calculations. We know the basement is 10 foot 6 inches, so we go 10.5. You guys can see that in the width dimension there. I know it's kind of blurry, sorry about that. And we've also already calculated that our wall length is 212 feet. So we put 212 feet in there and we hit calculate. And then it's going to tell us the amount of yards that we need, the amount of bags, 40 pound, 60 pound, 80 pound. I always go off of the yards, and I don't ever use 41.2, for example. What I'm going to do is turn this light back on for you guys so you can see. So I'm going to write right here, wall concrete equals 42 yards. Now we have to go footer concrete, and that's, again, that's only the basement, I'll put a slash and then another yardage over here for the top. But we also have footer concrete that we have to calculate. Again, I'm not going to choose anything different. There's some options you can do there, but I'm going to type in my dimensions. I know my footer is 8 inches thick. I know my footer width is 2 feet, and I know my length is more than 212. Why is it more than 212? Well, that is your walls. Total length of wall. What we have to remember is the footer sticks past on both sides of the wall by 6 inches. So if you calculate that, that's 1 foot on each side. So anytime you have a 90-degree corner, you have to add a foot. So basically, we know we have 8 corners. We need to add 8 feet. 212 plus 8 feet will now turn into 220. And then that'll give us a good calculation on the footer concrete, which says 10.86 yards. We're going to write, excuse me, daggone. Since I know we will have a little bit of extra concrete needed in our footers, and you don't ever want to underestimate, we're going to actually bump that up to 12, which is only 1.14 yards more than what we need. So now we've got our wall on the basement yards. We've got our footer yards. Now we got to go back to our 212 length. And we got to go now, instead of our width being the 10'6", we're on the first floor, so our width is 9 feet. And our thickness, instead of 8 inch, like our footer, we're going to go back to 6 inches because that's our width or our thickness in the wall. So what we have here is 6 inches of thickness, which is the wall thickness, 9 feet of width, which is the wall height, and 212 feet, which is the wall length. Calculate that, and it says 35.33, so we've got 42 and 36. So we'll have a total in this ICF pour, being the basement and the primary level and the footers, not counting the floor yet, we will have a total of 78 yards for the walls, 12 yards for the footer, and now we have to calculate our floor. The beauty of this is, even though this is a porch, we still have to pour a 4-inch pad on top of that porch. So essentially, I can calculate the basement floor as the 33 by 61, and then this porch will be included in that floor cost. So now what we do is we know we're going to pour a 4-inch basement. We know our width is 33 feet. And we know our length is 61 feet. That's going to calculate and tell us we need 24.85 yards for the porch and the basement floor. Once again, that's close to 25, so we're going to round that up to 26 to make sure we have at least 1 yard of extra concrete. 26 yards. So to get our total of yardage, 42 plus 36 plus 12 plus 26 equals, in this ICF pour, including the basement floor and the porch, we will have a total of 116 yards of concrete. That gives you guys all of the bill of materials. The rebar is already factored into the bill of materials with the ICF product because that all comes from one supplier. The concrete comes from a different supplier, which is a local supplier to us. But that gives you everything that I calculate for an ICF build when we're only talking about external walls and internal features. I state that because there are some external specific things that are needed for wall attachments, if they're attaching on the outside. If you're building a deck, that's a different style of attachment. There is no deck here, there's just a porch. We will pour an ICF stem wall for the porch, put some rebar in there and bend it over to attach the concrete porch floor to the stem wall. So if anything does happen to move, the entire house moves together. But there are no external attachments here. There are no roof systems that go outside of the ICF. Everything goes on top of or inside the ICF. So if I ever do another ICF quote where we've got all of the attachment points on the outside, that's a wind lock product. You can't use a galvanized product. You can only use galvanized products inside of the homes. I know they say galvanale never rust, but the bolts that or the self-tapping screws they use for those metal brackets are not engineered for external use. So on the outside, you use a plastic puck with a concrete anchor that goes into the wall, sticks out, and then you put your band board onto that concrete anchor and hold it on with a nut and washer. Hopefully that gives you guys a good rundown of all of the materials that are needed for an ICF house. And I hope you enjoyed the video. And as always, like, comment, subscribe.